All right, here we have some triangles that are in the coordinate plane, and they're kind of asking you to review here. This triangle ABC has vertices at 3, 6, 3, 1, and negative 2, 1. They are labeled here for us. Use either the Pythagorean theorem or the distance formula to find the length of, oops, AC is what this should say right here. Okay, so we want the length of this line. Notice we can't just count its length because it's on a diagonal. Okay, so instead we use what they asked us to, either the Pythagorean theorem or the distance formula. I will use both just so you can see both and select which one you would like. Okay, so I'm going to start using the Pythagorean theorem. Pythagorean theorem can be used anytime you have a right triangle, and we do have a right triangle here. Okay, and remember it's a squared plus b squared equals c squared. A and B are the legs, C is always the hypotenuse. So C is our length here that we're trying to find. A and B we can find just by counting on the grid. So how long is this side? It's 1, 2, 3, 4, 5 squares. Okay, so this side is length 5, and this side is length 1, 2, 3, 4, 5 squares also. So my A is 5 and my B is 5. I put those into the Pythagorean theorem. 5 squared plus 5 squared equals c squared. Remember that squared means to take a number times itself, so this would be 5 times 5 is 25. 5 times 5 is 25 equals c squared. I add my 25s together to get 50. And so I'm down to c squared equals 50. To solve this, I would need to take the square root of both sides to get rid of the squared. So my answer is going to be the square root of 50. I wanted it rounded to the nearest tenth. That rounds to 7.1. So that is how we find the answer using the Pythagorean theorem. The distance formula, on the other hand, if you choose to use the distance formula, the distance between any 2 points on the coordinate plane is equal to x2 minus x1, those are the x coordinates of your points, squared, plus y2 minus y1 squared. Add those together and take the square root. We're trying to find the length from A to C. So here is my x1, y1, and this is my x2, y2. Again, those are just the x and y from each point. So if I put those numbers from A to C in to my distance formula, that gives me the x from this point, negative 2, minus the x from point A, 3. We're going to square that. Plus, now I'm going to subtract the y's. So the y from this point C was 1, minus the y from point A, which was 6, and square that. Go one step at a time here. Negative 2 minus 3 is negative 5. 1 minus 6 is negative 5. Square each of those, remembering that a negative times a negative is a positive. Negative 5 times negative 5 is positive 25. Negative 5 times negative 5 is positive 25. So I get 25 plus 25 is 50, and then I take the square root of 50 and I'm done. So again, my distance is the square root of 50, which is 7.1. So you can see you get the same answer whether you use the Pythagorean theorem with this right triangle or the distance formula, finding the distance from point A to point C.